Welcome to my channel. Myself Rahul Onari. I am studying in Sri Venkateswar College of Engineering, Bengaluru. Semester 2nd, Section Infinity. Course title Introduction to Mechanical Engineering. Course called BACK 204D. And today's topic is about nuclear power plant. Understanding nuclear power plants. A nuclear power plant is a facility that generates electricity by harnessing the energy released from the controlled fission of nuclear fuel, typically uranium. These plants play a crucial role in meeting the world's growing energy demands while minimizing the environmental impact of traditional fossil fuel based power generation. By leveraging the immense energy potential of nuclear reactions, nuclear power plants provide a reliable and efficient source of electricity that is increasingly becoming an integral part of the global energy mix. How does a nuclear power plant work? Nuclear fission. At the heart of nuclear power plant is the nuclear reactor where the process of nuclear fission takes place. In this process, uranium atoms are split, releasing a tremendous amount of energy in the form of heat. Heat generation. The heat generated from the nuclear fission reaction is used to boil water, creating steam. This steam then drives turbines, which in turn generate electricity through an electric generator. Electricity generation. The electricity generated is then distributed through the power grid, providing a reliable and consistent source of power to homes, businesses, and industries. Components of nuclear power plant. Reactor core. Reactor core is the heart of the nuclear power plant where the nuclear fission process takes place. It contains the nuclear fuel, control rods, and coolant systems that regulate the chain reaction and heat production. Steam generator. Steam generator is responsible for converting the heat generated in the reactor core into steam, which is then used to spin the turbines and generate electricity. Turbine and generator. The steam from the steam generator is used to spin the turbines, which is turn drive the electrical generators, converting the mechanical energy into electrical energy that can be transmitted to the power grid. The nuclear fuel cycle. Uranium mining. The nuclear fuel cycle begins with the mining and extraction of uranium ore, which is the primary fuel used in nuclear power plants. Uranium enrichment. The extracted uranium ore is then processed and enriched to increase the concentration of the fissile isotope U-235, which is necessary for the nuclear fission reaction. Fuel fabrication. The enriched uranium is then converted into nuclear fuel pellets and assembled into fuel rods, which are loaded into the reactor core of the nuclear power plant. Spent fuel storage. After the fuel has been used in the reactor, it becomes spent and is removed. The spent fuel is then stored in specially designed pools or dry cask storage facilities to allow for the radioactivity to decay over time. Key features of nuclear power plants. Contaminated structures. Nuclear power plants are designed with robust contaminated structures that are engineered to withstand natural disasters such as earthquakes and prevent the release of radioactive materials in the event of an accident. Multiple redundant safety systems. Nuclear power plants have multiple redundant safety systems including backup power sources, emergency cooling systems, and automatic shutdown mechanisms to ensure the safe and reliable operation of the plant. Rigorous regulatory oversight. Nuclear power plants are subject to stringent regulations and extensive safety inspections by regulatory authorities to ensure the highest standards of safety and security are maintained. Ongoing monitoring and maintenance. Nuclear power plants undergo regular monitoring, maintenance, and upgrades to ensure the continued safe and efficient operation of the facility, as well as the protection of workers and the surrounding community. Environment Impact of nuclear power. Low carbon emissions. Nuclear power plants do not produce greenhouse gas emissions during operation, making them a valuable asset in the fight against climate change and the transition to a more sustainable energy future. Radioactive waste management. The management and safe disposal of radioactive waste from nuclear power plants is a significant challenge that requires careful planning and long term storage solutions to minimize the environmental impact. Ecological considerations. The construction and operation of nuclear power plants can have localized impacts on the surrounding ecosystem, such as the use of water for cooling and potential for accidental radioactive releases. Public perception. The public's perception of nuclear power and its associated risks can influence the development and acceptance of nuclear energy as a viable energy source, underscoring the importance of transparent communication and public engagement. Advantages and disadvantages of nuclear power. Advantages: reliable and consistent electricity generation, relatively low operating costs, minimal greenhouse gas emissions during operation, small land footprint compared to other energy sources. Disadvantages: concerns about nuclear waste disposal and storage, potential for catastrophic accidents with severe consequences, high upfront capital costs for plant construction, public skepticism and concerns about nuclear safety. The future of nuclear power. Technological advancements. Ongoing research and development in nuclear technology, including the design of advanced reactor types and the improvement of safety systems, are paving the way for a new generation of nuclear power plants that are safer, more efficient, and more cost effective. Sustainable energy mix. As the world strives to reduce its carbon footprint and transition to a more sustainable energy future, nuclear power is increasingly being recognized as a vital component of diverse and balanced energy portfolio, complementing reliable energy sources such as solar and wind. Policy and regulatory frameworks. The future of nuclear power will also demand on the development of robust policy and regulatory frameworks that addresses concerns about nuclear waste management, safety and public perception, while providing the necessary support and incentives for the continued development of nuclear energy. Thank you for watching.